Thank you. Thank you. Hi, good evening, everybody. My name is Andrew Lynn from Supermicro and based in Taiwan to support this OCP event. Today we're going to share how we're going to implement our Supermicro GPU servers for accelerating advanced AI. First of all, let's talk about the AI market. As we all aware that AI markets grow very, very fast, especially those couple quarters. And we see from the market intelligence that we have a compound annual growth rate up to 38.1% from 23 throughout 2030. And there are market share 42 in North America, but where you see Asia Pacific also very strong growth here in the AI market. And also the revenue up to almost 1,600 billion by 2030. And especially for ChatGPT, as you see that it's a record-breaking record for their subscription users. And it only takes 5 days to get first million users. And the other, those giants, they need to take a couple years to reach their numbers. And as we also aware that ChatGPT or current AI, we already can do very extremely good job than human beings. So you will see the AI is now. But we saw a lot of the AI or HPC people talking about, but what's the difference between AI and HPC? I would say AI community doesn't know how much HPC problem they will encounter. Or we can say AI is still in its infancy stage, or at least they are still in their childhood. So that is still a long way to go. So that's why people still encounter a lot of new challenges before we really reach that goal. And secondly, they all dealing with very compute-intensive problems and handling huge amount of data, share same hardware, software. So that's why when you're talking about AI applications, especially in hardware, a lot of people also mentioning about HPC. That's the reason why. Sorry. So how we accelerate the hardware arena for the HPC or AI? I would say in early stage when we have resolved HPC problems, you will see the utilization of CPUs, sometimes they are not even. Some of the CPU usage is quite high, some of the CPU, I mean the core. The CPU core, some of the applications not really can drive every single core from the CPUs. But when we start using accelerator, I mean, especially for GPU, a lot of applications, the job has been dispatched to the GPU. So people quite a while not talking about the power of CPUs. But for AI, especially for ChatGPT training, we noticed that not just GPU and also GPU, every computing power has been driven to extreme numbers. For example, if our GPU systems can run up to 6,000 watts, when we run the ChatGPT, it also almost reached that height. So in this case, every resources in the servers or GPU servers really count. So in this case, you will see the architecture of this newest GPU. This is H100 systems made from Supermicro. two CPUs, and we have H100 GPU here. And we all know that the speed of the interconnect by using NVLink, which is up to 900 gigabytes per second, transportation between GPU to GPU. But the other important thing is how we gonna make so much huge amount of data to put into GPU servers. So that's another challenge. So in this case, we have to make sure our local storage good enough or big enough. The first thing is we got to have proper many right numbers of NIC. For example, people using InfiniBand to transport a huge amount of data into the server systems. And we also need a very quick flash, like NVMe, to store if the data not yet being processed. So this is very key to populate a proper number of NIC or InfiniBand or NVMe storage so that you can keep your GPU or CPU running, not waiting. So we have some cases before for people deploy their AI solutions. Customers, their server farms, GPU farms, only use 30% of their capacities. The rest of the 70% are waiting for data input. So that's the importance of these NIC card numbers and also the depth of this NVMe storage. So here's the systems that we introduced for H100. People call it Delta Next right now. And this system is Redstone, almost the same configurations, but use less GPU. They only equipped with 4, we call Redstone. And this is how we optimize our hardware by not just using best-in-breed GPUs, but also we equipped the proper InfiniBand, NIC card, bandwidth, and also storage, local storage. But for the PCIe-based, we have different configurations. Here's the CPUs, your GPUs. But remember that this is direct attached CPU and GPU. And we have a switch like this, and we equip this group of 4, and this another group of 4 under different CPUs. And in these configurations, we have these connections. And I will show you the difference later. Or we not just put it in with the CPU, but with the other PCIe switch. So here's the difference. As we know that the communication between GPU and GPU is so important for AI training. So in this case, we tried how we reduce the latency between GPU and GPU. Here's the story. When our GPU 1 and GPU 2, they need to talk to each other. Like this dual root, we call this dual root because they come from different CPUs, right? From 1 to 2, it's in the same root, so the latency only 6.6 microsecond. 1 to 4, the same, but 1 to 8, you have to cut across over here, down to here. So it would take 3 times more latency. But for this single root, we call this single root. Even 1 to 8, it's almost the same, no big difference. So here's how we optimize our structure to make the latency as lower as we can. And of course, we know NVIDIA, they also provide the other solutions. They call NVLink Bridge. Once you have NVLink Bridge, you can have quicker communication between the two. So that will also benefit the overall GPU training, AI training. And this is the other difference. If we put this link down to here, we can get better even performance between all those GPUs. But the cost of this is top speed a little bit lower than this one. So it really depends how model you are running for your AI servers. And this difference, for some people, they may make sense, but for some people, they may not really need. So it's really depends on what applications we are running. And here's the Supermicro offering, no matter from edge or to cloud, to training, from training to inference. We have different products with different architectures so that it can fulfill different needs in this market. And also, if we check the real models, we have all those models just for AI servers. This is not all Supermicro offering. These are just GPU AI servers. And we have different platforms, whatever you like for the AMD, Intel, or you want NVIDIA GPU, you want the AMD GPU. And even we have some more to come. For example, like ARM-based. We probably can show you next time when we have chance. Okay, so the next challenge, as we have another track in track number 1, the whole series talking about the liquid cooling, exactly. Next challenge will be the thermal issues. So Supermicro also offer cold plate cooling solutions, immersion, and chill door. We have everything solutions to offer to the market. Let's talk about this first, because I will talk it quicker. Immersion is not really massive deploy yet, but a decade ago, Supermicro already starting supporting a lot of proof of concept, POC projects in many countries in the world. But there's not big volumes, but only small experiment about the thermal issues. But now, from this year, getting more and more customers asking for these kind of solutions to provide to them. And one country in Asia Pacific area, they got a huge fund and going to build a data center based on immersion. So you see a lot of demos, our partners outside of those 2 days, they already offer the immersion cooling. And good news is they are going to be mass deployed. It's about time. But it's okay, but it's still early, right? It's still early because we are not yet resolved the density, the utilization of space densities, right? So it's not really, I mean, not everyone will use that so far. So let's talk about the cold plate cooling. Here's our offerings. Supermicro, we have the solution like this one, and cold plate for every different models. And we only use cold plate put on top of CPU, for example, and GPU, of course. And for some other cases, we may also need to cool down the memory or some other power modules or something like that. But in most of our cases, we only need to cool down a CPU and GPU. So that's why in this case, we still need to have the system fan keep running, but with very slow speed. And they can keep their airflow blowing so that we can still dispatch the heat, a little bit heat from inside the chassis to outside the data set, to outside the chassis. And here's the solutions. We have, number 1 here is the cold plate. And 2 is this we call CDM, coolant distribution manifold. And so that internal circulations here down to a CDU, it's a coolant distribution unit. And so that we have another outer loop that will transmit those heat to the data outside of data centers. So here's our solutions. And we almost all our product have the solutions with using both air cool or liquid cool. And here's the just some pictures, because we are almost very late today. Just to show you some pictures. This is the immersion, right? And this is the actual deployment in Japan a couple years ago. This is our phase 1 liquid cool solutions. And all you see here is just cooling pipe. It's not yet include networking. I think we already have a power plug plugged in already. So quite complicated. And in our last generation, we put CDU on top of the rack so that you will see the huge pipe over here. But our new generation, we put this down to the bottoms. So people will feel more secure if you worry about some leakage. But of course, we've done a lot of aging tests. We have 100% guarantee that our cooling solutions never leak it. And also, I would like to go back last page. Our pump over here, we have redundancy. So they are both work together in normal situations, but once there's one failure, the other one will take over the whole job. And the failure one, you can do a swap, a hot swap, to make everything back to work. Okay, so here's another picture in our manufacturing. That's the people doing the tubing. There's another one. Okay, and this is new generation, our cooling solutions. Okay, and I still use this to introduce your investment in CapEx investment will be around 2% to get liquid cooling. But your OpEx for the utility gonna down 32% in this particular case. It will vary from project to project. It really depends on how much, what's the server type you are purchasing. For example, a GPU server, it's gonna very, very expensive compared to a liquid cool. Or the regular server, or density servers, or entry server, they will have all different numbers. But based on our calculations, you will see for Korean, you take nearly 20 months that you're safe from utility. You can buy the entire liquid cool solutions. But your system not just run for 2 years, right? At least 5 years, or maybe longer. So the rest of the years, you're gonna make returns from using liquid cooling solutions. So let's pretty much cover liquid cool part. And I would like to say a very important part for Supermicro is since we starting to deliver liquid cooling solutions, so that's better for our customer to purchase not just Supermicro servers. It's better to purchase the whole rack because we will do everything integrated into a rack. And the true story for this is when we deliver the whole rack with cabling everything to the customer side, and when we finish the installation and power on, it start to work up and running on the same day. It's a record-breaking deployment, because for the similar case from some other competitions, they put rack into the data center first and reinstall the servers one by one, a switch, storage, everything, and then start cabling, powering, and everything. It start to test the system at that time. And it sometimes take more than 2 months, not yet start to run. And this is the real case we encountered before. So what we done for rack level solutions, of course, analyze the applications, power budget, rack layout. When we have rack layout, that means we have the topology of the whole systems, including switch, how's the performance you need, how many switches, how quick, and also your spine, you leave everything, you got to have answers so that we have everything planned and then start to do layout. Assembly in our factories, configurations, including OS software, everything, and testing in our lab, so that after that, we deliver to our customer side. So that's the real story we deploy to our customers. And this is one case. A top-notch semiconductor manufacturer, they encountered the problems, and we work together with them, not just GPU servers. We also provide the flash, tier 1 storage, and tier 2 cold storage as a total solution to them. And this is the real case. We put it on the same day and make the system run. That's the case. Okay, and this also, we help them resolve the issues, because when they are starting using these systems, like I say earlier, we have the systems, GPU systems spend 70% of their computing power waiting. And this is exactly the case. So it's pretty much cover my part for introducing Supermicro GPU servers. And this is the right servers that were used for a lot of our AI customers, especially with generic AI. The needs for these GPU servers is really, really tremendous, huge since this year. We have huge back orders to fulfill US giant players, not just US, starting get the strong feedback from Asia. And Asia countries, we are seeing Korea is the very important one, Japan also the very important one, China. So those 3 countries, very, very important customers for AI market. So here's about my all presentations. So thank you very much. Do you have any questions about my presentations? If no, thank you very much. It's a long, hard day, and thank you.